Dang, Camille. I wish I knew some physics. I don't know any physics. What are you laughing at?
Well, it's true. You don't know any physics.
Like your freaking physics professor right here? You take a high school physics course, Camille. It's not like you know any more than me. We take the same class.
I wish we had someone that would teach us physics. Hey guys, I heard you wanted somebody to teach you physics. Well, I'm here to teach you 3 cool concepts about physics that relate to this car that you're sitting in right now.
So now that talking sponge is gonna preach to us.
That's right, kids. So first we're going to talk about Newton's first law. Newton's first law states that an object in motion stays in motion and an object at rest stays at rest unless acted on by an outside force. In the case of this car, if we are driving along and I happen to accidentally maybe slam the brakes, Ali here, who's sitting right there, will jerk forward, but this seatbelt is an object that will keep her in her place.
Jesus Christ! I didn't know that was...
Now I'm going to tell you about my second concept, centripetal force. Centripetal force is a force on an object directed to the center of a circular path. Its value is based on 3 factors. 1, the velocity of the object as it follows the circular path. 2, the object's distance from the center of the path. And 3, the mass of the object. Alright, so now I'm going to whip out my handy dandy calculations paper and pen, and I'm going to teach you how to calculate the centripetal acceleration. So the equation is AC is equal to V squared over R. That's the centripetal acceleration is equal to the velocity squared divided by the radius. So basically, if you want to find the centripetal acceleration and the velocity is, let's say, 5 meters per second squared, well, you'd have to square it because the velocity is squared, divided by 10 meters if that happened to be the radius of the circular path, then the centripetal acceleration would be 5 times 5 is 25, divided by 10 is 2.5 meters per second squared. That's the answer. So now I'm going to teach you guys how to calculate the centripetal force. Basically, the equation is the same as the regular force equation, except for you add little c's next to it. So it's the centripetal force is equal to the mass of the object times the centripetal acceleration. As we know from before, the centripetal acceleration was 2.5 meters per second squared. And let's say the mass of our car is 1,000 kilograms. You'd multiply that by 2.5 meters per second squared. And then so you'd get the centripetal force is equal to 2,500 newtons. 2,500 newtons. That's the answer. Now I'm going to teach you guys about Newton's third law. Newton's third law states that for every action there is an equal and opposite reaction. So that means that if 2 objects hit each other or apply any amount of force against each other, each object will apply the same amount of force. So if I happen to hit Camille with my car, she will be applying the same amount of force to my car that my car will be applying to her.
Oh no! Wow, we learned so much physics from you, Taylor. Wow, Taylor, we really learned a whole lot.
That's what I'm here for, guys. See you on the flip side.
Come here. What? Do you have a driver's license?
No. Do you?
No.
Taylor! Hi guys. Did you say? Let me redo that. Hang on. I'm not ready. Hang on.
Now that's physics in its purest form right there. Object at rest stays at rest. Just like that beautiful dog right there. That's a good one. That's a good one. Stop laughing.
I'm gonna cry.
This is awkward.
Yes, Camille. Precisely like a merry-go-round. You have to! Wow.
Oh, so now they're talking. I didn't realize we were going.